Assalamualaikum, my name is Akmal Zafran and my metric number is 2410911099. So today, me and my partner will be presenting an Electronic Lab 2 operational amplifier using LT-Spice with the configuration of OP amplifier with inverting and non-inverting amplifier, integrator, differentiator, and summing amplifier. In the left section, we will conduct 5 experiments, and it is important to prepare the pre-lab calculation because we will compare the pre-calculation with the value of the experiment. So today I will presenting inverting amplifier. First, with inverting amplifier, we have R1 and R2, where the value is 1000 and 33,000, with the input of 1 volt with 1000 sine wave 1 hertz. So this is the schematic circuit that I have built, and this is the input V1 and this is the output V out. So based on the wave, we can see this is V in with the value of 1 volt and the V out with the value of 13 volt. This is what we call a inverting amplifier, where the waveform from V in is different with V out. Next, this is our second circuit, that is non-inverting amplifier. This is my non-inverting circuit that I have built, different than the first one because the V in is over here connected to the positive value of the LM741, and this is the output, and the value of R2 is different from the inverting circuit because the other one is 33,000 and this one is 10,000. And based on the waveform, we can see there is no different at all, and the V out value is 11 volt, while the V in value is 1 volt. We can see there is no different shape of the graph. We can see it is still the same, but with the different value from V in and V out. Okay, this is our third circuit, is integrator configuration. This is our schematic, and there is some changes with this circuit, where is the RS resistance with value of 100k, and our RF, or in the circuit R2, is 10 mega ohm. And we have additional component. There is a capacitor with the value of 0.01 micro. And for the supply, we have the V initial equal to 1, V on is -1, where the delay is 0, and the T rise is 1 micro, and T fall is 1 micro, and T on 0.5, and the period is 1 milli, and T on is 0.5 milli. And for the waveform, we have the VE equal to 1V and 1000 Hertz square wave, and the output is pulse, and the value for the V out is, we get one we get 0.9 volt. Yeah, And the for the V in, yeah, we get -1. That is it for the integrator circuit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin Muhammad Zamri. My number matric is 241091134. Today I would like to presenting about schematic D and E. D is for differentiator and E for summing amplifier. So this is schematic D. We use two resistor and two capacitor. For first resistor we use 100 kilo ohm. Second resistor is 1 kilo ohm. First capacitor 100 picofarad. Second capacitor is 0.01 microfarad. So this is a complete circuit for circuit D. So we move to the next is waveform for graph. V out is we get, this is V out, we get 2.4 V. So based on calculated and experiment, for calculated for D differentiator is -1 volt. For V out in experiment is -2.4 volt. So that's all for schematic D. So now we move to the next is E summing amplifier. So summing amplifier we use three resistor that is including R1 10 kilo ohm, R2 is 2 kilo ohm, R3 is 10 kilo ohm. So for circuit summing amplifier that we use two component OP AMP LM741. So for pass is sign 0, 1 and 300. So this is a complete schematic for E summing amplifier. So next we move to the graph of waveform for summing amplifier. So based on the V out that we get is -6 volt. So this is a V out for summing amplifier. Based on calculated and compared to experiment, calculated we get -6 volt. Also experiment we get -6 volt. So that's all for me for schematic E summing amplifier. Thank you very much. So I would like to share about conclusion for lab 2. So based on the lab 2 that we already explained from this lab, the key findings show that each operational amplifier configuration behave exactly as predicted by its theoretical model. The inverting and non-inverting amplifier produce gains that closely match the calculated values, proving that the relationship between resistor ratios and voltage gain. The integrator and differentiator circuits successfully demonstrate how OP-AMPs can perform mathematical operations on signal, while the summing amplifier confirms the ability of OP-AMP to combine multiple inputs into a single output. So that's all for me. Thank you and Assalamualaikum warahmatullahi wabarakatuh.